All right, let's now look at the definition of radians. So radians is another unit of rotational measure that is very common. And radians, uh, where it originates from, actually originates from a circle itself. One of the first equations we're going to be looking at is this one. And so what this equation says is that the rotational angle is equal to the length of an arc divided by the radius of that arc. So, what does that look like if we were to, actually draw that? So let me draw a quick little arc here. Okay. So the arc length, which is represented by the letter S, that's this piece of the circle, but it's only a piece of it. Okay. The radius, okay, is the radius of the arc, and that goes from the edge of the circle to the center of the circle, or the center of the rotation. And so if you know the arc length and you know the radius, then the arc length divided by the radius will give you this rotational angle in radians. So that is what that equation means. Now, this equation actually stems from the definition of how we get pi. So how do we get pi? Well, pi is equal to the circumference of a circle divided by its diameter. So if we take a circle, their circumference is the distance all the way around it. So if we start here and we measure the distance as we go around the circle, and we end up here where we started, that distance around it is called the circumference. And the diameter is the length of the line segment from one edge of the circle to the other edge, but it has to go through the center of the circle. So that distance from there to there is the diameter. So if you take the circumference of a circle and you divide it by its diameter, what you get is pi radians, or 3.14 ... radians. So just the number pi that you're maybe familiar with on your calculator. You may have seen pi being represented as 3.14 in other classes or in other contexts. This is where pi comes from. Pi comes from the circumference of a circle divided by its diameter. So it doesn't matter if the circle gets bigger, its diameter will get bigger. And when you do the division of those two, it comes out to 3.14. If you take a smaller circle and you compare its circumference divided by its smaller diameter, that still comes out to pi. Okay, it's just a ratio of one part of a circle to another part of the circle. So down below, I've got some visuals kind of maybe further reinforcing this idea, where we've got, arc length being equal to 1, the radius of the circle being equal to 1. And if you look at arc length and radius as being the ratio of 1/1, then that gives you a rotational measure of 1 radian. So this is a 1 radian rotation. Keeping the radius the same, but if we increase the arc length by 2, if the arc length is now 2, we keep the radius at 1, a ratio of 2/1 gives us a 2 radian rotational measure. And if we go one step further, and if we increase the length of the arc, so the distance around the circumference to 3, okay, you can see that's 3 times longer than what we started with. We have an arc length of 3 with a radius of 1, and that ratio of 3 to 1 is 3.0 radians. So that's a 3 radian rotational measure. And notice that 3 radians around is almost, right? It's almost all the way halfway around the circle. Halfway around the circle is actually pi radians, which is 3.14. 3 is almost 3.14 radians around. Okay. All right. So that just shows, 3 examples of this relationship between arc length and radius and how that equates to radians of rotational measure. So let's now, push on further and let's look at calculating this, ourselves. So here I've got an example first and a think pair share second. So this is asking us to calculate radian measure. So if the radius of the arc is 2 and the length of the arc is 3, then what is the rotational angle? So let's maybe try and draw that really quick. So we have a starting point, and here's the center of our circle. The radius is equal to 2, and our arc length, and I'm just kind of making this up because I'm not really sure where it is, but our arc length is 3. Okay, so the length of this arc is 3. Then what we want to know is what is this angle in radians. So what we do is we use this formula that we had up here. So our rotational angle in radians is equal to arc length divided by radius. So our arc length was 3. The radius is 2. And 3 divided by 2 is 1.5. So this rotational angle in radians is 1.5 radians. All right, so all we had to do was use this initial formula, plug in the values, and the only thing that was unknown was the angle that we were looking for. Okay, so here's a think pair share. This is where if we were in a classroom, I'd have you guys work together, and after a few minutes, we'd kind of share our answers. So go ahead now and pause the video, see if you can do it, and then resume if you need some help. Okay. So with this one, the radius and the arc length is different, okay, but we're still tasked with the same problem, which is to calculate the rotational angle. So we use this formula. The rotational angle in radians is equal to the arc length divided by the radius of the arc. And the arc length here was 22, and the radius is 5. So now we want to do 22 divided by 5. So let's just kind of do that really quick. So we'll just do 22 divided by 5. And you can see we get 4.4. So our rotational angle in radians is 4.4 radians. Okay, now we can take this relationship of theta in radians over arc length times radius, and we can do a little bit of manipulation of that. So let's take this original equation and let's multiply both sides by r over 1. The r's will cancel, leaving us with just arc length on one side. And on the other side, we have the radius times our rotational angle in radians. So what this means is instead of trying to solve or figure out what the rotational angle was, what if we know the rotational angle and we know the radius, but we just don't know the arc length? We can calculate the arc length instead. So we've just taken that original formula and rewritten it a little bit. So these variables have the exact same meaning as they did before, except now the way it's set up is it's going to help us calculate arc length now instead. So let's look at this example and this thing pair share. So it says if the radius is 7 inches and the rotational measure is 1 radian, then what is the arc length? Okay, so if we draw a picture of this, all right, so we have a radius of 7. That's this distance. And we know that we've got 1 radian of rotational measure. So this angle is 1 radian. Then what we want to know is how long is this arc? So we know the radius, we know the angle. What is the arc? Let's see here, let me get that little object. Okay. So we can now use maybe this form of the relationship between those variables. So we have S equals R times theta radian. The radius is 7 inches, and the angle is 1 radian. Now, when you do this calculation, in this case, you do not need to use radians. You have to have the angle in radians. You can't have it in degrees. It won't work out otherwise. So our arc length is 7 inches times 1, or just 7 inches. Okay, so this was a pretty straightforward example. So our arc length is 7 inches. Here's another thing pair share. Give this one a try on your own. Resume the video if you need some help. All right, go ahead and pause. Okay, we're back. So in this one, it says if the diameter is 20 centimeters and the measure of rotation is 4 radians, then what is the arc length? Okay, this one is throwing a little bit of a curveball at you because before we were given the radius. Now we're being given the diameter. Well, in order for you to use this equation, r represents the radius, not the diameter. So what we need to do is we need to recognize that the radius is equal to half of the diameter. So if our diameter is 20 centimeters and we divide that by 2, then that means the radius is 10 centimeters, and that's the value we need to use. So the arc length is radius times our rotational measure in radians. Our radius is now 10 centimeters, and our rotational measure is 4 radians. 10 times 4 is 40. And we're talking about a length, so we have to put the unit of length. So that's 40 centimeters. And that's the answer to that. Okay, so, on this page, we looked at how to get the rotational measure given arc length and radius, and how to get the arc length knowing the radius and the angular measure. Let me know if you have any questions.